In this video, we are going to talk about 7-segment 2-digit LED display. But before getting to the 2-digit display, let's talk about just a single 7-segment display. It has individual segments to display different part of numbers. As you can see, it has 1, 2, 3, 4, 5, 6, 7 and 8 segments. But the name says it's a 7-segment display. But it has 8 segments. Why's that? The first 7-segment display was made in 1968. During that time, it consists 7 segments to display numbers. Later, it got updated with an extra segment to display decimal point. That's why today's 7-segment display has 8 segments. It offers great contrast because of using LEDs for the segments. It's easy to manufacture, easy to use, and cost friendly. It is widely used in digital watches, calculators, microwave ovens and washing machine displays, and it's also used in airports, metros, and hospitals. Let's see how it works. To start the 7-segment display, first of all, we need to connect both the common pin of the display together. If it's a common cathode display, you need to provide the common pin with ground, and if it's a common anode display, you need to provide common with a positive voltage. Here in this case, our display is common cathode, so we are going to provide ground to our common pin. To turn on the individual segments, that is segment A, B, C, D, E, F, G and dot point, we need to connect it with VCC, as you can see here. We can absolutely connect our 7-segment display with an Arduino because it needs around 9 pins. And in total, our Arduino has 16 usable pins. But what if we want to use two displays together and make it as a 2-digit display? We need 18 pins in total, but our Arduino has only 16 pins. So how are we gonna use it? The answer is multiplexing. Multiplexing is a technique used in communication systems to combine multiple signals into a single transmission medium, or you can say a channel. This allows for the efficient use of resources by enabling multiple data to share channel without interference. There are majorly 4 types of multiplexing: time division multiplexing, frequency division multiplexing, wavelength division multiplexing, and code division multiplexing. Here in this case, we are going to use time division multiplexing to run our display. Now the question arises, how multiplexing will help us to run this display? It enables us to use fewer channels or wires to control the 2-segment LED displays or more. It reduces the overall power consumption of the device because in Arduino we can only take 10 milliamps from any GPIO pin. It helps us in simpler wiring. It also reduces the cost of the devices and it enables us to efficiently use the available resources. Multiplexing is widely used in LED displays, Wi-Fi networks, cell towers, computers, robotics, and even in FM radios. Let's see how to prepare two 7-segment displays for multiplexing. Let's connect the segment pins together and connect the common pins of both the displays separately. As it is a common cathode display, if we connect ground to both our display 1 and display 2 common pins and apply a positive voltage to a segment pin, we can display different numbers. This clever circuitry reduces the total number of pins required to run these two displays from 18 to just only 10. But what if we want to display 10? How are we gonna do that? The answer again is multiplexing. We're going to rapidly switch the state of the display to show the digit 10. Connect the ground pin of the module with ground of Arduino. Now connect the display select 1 of the module to digital pin 4 of Arduino, followed by the display select 2 pin of the module to digital pin 5 of Arduino. Now connect the segment A pin to Arduino's pin number 6, B to 7, C to 8, D to 9, E to 10, F to 11, G to 12, and decimal pin to digital pin 13. Let's start coding. First, we need to set the segment pin as output with the help of pinMode function. So let's do that for every segment. Now we need to do the same thing for our display select pins. So let's do that. As you can see, we have already initialized all our display pins as output. Now we are going to create digit functions so that we can reuse them again and again in our code. Each function will contain the value of all the segments, either on or off, to display a particular digit on the display. As you can see, we have created all the functions to display each digit on our segment display. Let's use them in our loop function to display numbers 0 to 9. We also need to activate our display 1 and 2. As we already know, it's a common cathode display, and that's why we need to send a low signal to our display select pins. Now we have activated both our displays with a low signal. Let's see it working. As you can see, we can display numbers 0 to 9 on both our displays. Now let's display 10. And to do so, we need to use time division multiplexing by activating display 1 and deactivating display 2 and calling 0 function, and then deactivating the display 1 and activating the display 2 and again calling the 1 function to print 10 on our display. Let's also add a really small delay in between, that is of 10 milliseconds, so that each display can get fully turned on before moving to the next line of code. Now let's put these things in a for loop function so that the display switches between 0 and 1 for at least half a second. And to do that, we need to run the for loop function at least 25 times. Because of the delay, we are holding our loop for 10 plus 10 milliseconds between switching, that is a total of 20 milliseconds. So 500 divided by 20 is 25, and that's why we need to run this loop at least 25 times. Now it's time to upload our code. and see the multiplexing with our own eyes. And with this, we are able to display individual numbers on our segment display with the help of multiplexing. Now you can try displaying different numbers using the same concept, that is multiplexing.